Hi there, and welcome to this video tutorial. If you are taking statistics and probability class, then you came to the right video. In this video, we will be talking about the concept of random variables. Now, are you ready? Let's get started. But before proceeding to this video, let's try to go over with the learning competencies for us to be guided in this lesson. At the end of this lesson, you are expected to achieve the following. First, illustrate a random variable, both discrete and continuous. Second, distinguish between a discrete and a continuous random variable. Third, find the possible values of a random variable. And as a general reminder, you can supplement yourself with other learning materials using the other platforms, including the printed materials. Next is to write down your thoughts to help you in processing information. Also, keep in mind that your success in this lesson depends on how much effort you put into doing the activities provided in this lesson. And of course, you can also pause, go back, and view again this video lesson if you find it necessary to do so. I know it's gonna be difficult, but I always believe that it is not impossible. All we have to do is to embrace difficulties, welcome challenges, and always think positive as we all face this new normal in education. Now, what is a random variable? A random variable is a variable that can take on values based on the outcomes of a random experiment. They are often designated by capital letters. There are two types of random variables. First is the discrete random variable. It is a variable that can take only whole number values and outcomes that are countable. Random variables are associated with experiments for which there are a finite number of possible outcomes. Let's have the following examples. Number of students present. Number of color pencils. Students' grade level. These numbers cannot be decimals nor fractions, thus, they would only take and represent whole numbers. The second type of random variable is the continuous random variable. Continuous random variables are variables that can have any values within a continuous range. Like decimals and fractions, they are associated with infinitely many possible outcomes. And the number of objects are not exactly whole numbers. For example, height of students, the distance traveled by a biker, and the weight of a newborn baby. These values may not take exactly whole numbers, but may represent decimals and fractions. Now, let us have some examples in finding the possible values of a random variable. Suppose a coin is tossed 3 times. Let x be the random variable, representing the number of tails that occur. Find the values of the random variable x. The first thing we need to do is to determine the sample space. We then let h to represent the outcome when it is a head, and t to represent for a tail. Take note that the coin is tossed 3 times. So we will have the first toss, the second toss, and the third toss. And there are 2 possible options that will occur for every coin. Either it will land on the head, or the other way around, which is the tail. For an easier way of visualizing it, we will construct a tree diagram. So, we have it here, the first toss, the second toss, and the third toss. In the first toss, there are 2 possible outcomes. It could be that the coin will land on the head, or it could also be that the coin will land on the tail. Now, let us start with the head. In the second toss, there are also 2 possible outcomes. Either the coin after tossing will land on the head, or it will land on the tail. As we continue for the third toss, the third coin may land on the head, giving us a final outcome of a head combination. Meanwhile, the third coin may also land on the tail, which would give us a final result of a head, and tail combination. Continuing the process for the second option, with the second toss which landed on the tail. It would also give us 2 possible options. Whether the coin will land on the head, which would result to a head, tail, head combination. or it may land on the tail, giving us a head, tail, tail outcome. Now, let us continue the coin which landed on the tail in the first toss. In the second toss, there are also two possible outcomes. Either the coin after tossing will land on the head, or it will land on the tail. Proceeding to the third toss. The third coin may land on the head, or it may land on the tail. This then gives us a final outcome of a tail, head, head combination, and tail, head, tail outcome. Meanwhile, as we continue for the third toss with the coin which landed on the tail in the second toss, there are two possible options in the third toss. Still, we have the head, which will give us a final outcome of a tail, tail and head combination. Or the third coin, upon tossing, will land on a tail, with a final result of a tail, tail, and tail outcome. Great! We are done showing the possible outcomes using the tree diagram. Therefore the sample space for this experiment is TTT, TTH, THT, HTT, HHT, HTH, THH, and HHH. This time, let us now proceed to step 2. In step 2, we will count the number of tails in each outcome in the sample space, and assign this number to this outcome. From the results and possible outcomes using the tree diagram, we will only count the number of tails. Since in the given problem, we are asked to find the values of the random variable x, which denotes for the number of tails. So in this table, we have the two columns representing the possible outcomes, and the value of the random variable. We have h, with 0 as the value of the random variable since these are all heads and there are no tails. Second, is HHT, with the random variable 1 since there is one tail. Third, HTH with 1. THH, with also 1. HTT with 2. THT with also 2. Same with TTH with 2. And lastly TTT with a random variable since it consists of 3 tails. With all these values that we got, we can say that the possible values of the random variable x are 0, 1, 2, and 3. And that's it. Now you are ready to answer your exercises. I hope you learned something from this video. Thank you for watching. Up next, watch the continuation of this video about constructing probability distributions. Don't forget to click the subscribe button and hit the notification bell for more updates. Thank you so much. Yours truly with love, Sir Herms.